We are going to start a new unit, that is 2D finite element formulation. So previously we have seen 1D element analysis, in which we have analyzed 1D bar element, truss element and beam elements. And so before starting this, there a picture shows your different types of elements. So there are basically three types of elements. The first one is a simplex element. Second is a complex, and third one is a multiplex. So generally nowadays multiplex of elements are used, that is a quadratic, hexahedron and octahedrons elements are used. So in this figure you can see this one two node bar element. So this is a link element. You can consider as a link element having two nodes. Okay, then again suppose a triangular element. So in 2D this entire you consider as a one element. Okay, and in 3D, so this is in 2D, this is your 1D, and in 3D suppose a tetrahedron, we consider a tetrahedron. Okay, and so it has four nodes. So this is a 3D linear analysis. So it comes under this first simplex element. Okay, so what is about the complex elements? Complex elements, suppose considering the first this 1D element, what will be differ is that it has an intermediate node. So in this 2D also it will become in this way. So node will increase to intermediate nodes. So this is a complex type of element. So in the third element, that is a multiplex. So in this figure you can see this this three noded tetrahedron. Okay, and then this this cubical 3D noded brick hexahedron. So these are the multiplex elements. So today we are going to see the interpolation functions used for each type of this elements, that is for simplex, complex and multiplex, and this will clear the basic fundamentals for solving the interpolations problem, then plane stress problem, plane strain problem, then axis symmetry problem. Okay, so which is included in this unit. Okay, so what are the interpolation functions? So interpolation functions for these three types of elements we are going to see now. So suppose for 1D element, this two node link element we are going to, then what will be the interpolation function? Then t equal to a1 plus a2x. Okay, and suppose for complex x, this I increase a node in between this. So t equal to a1 plus a2 x plus a3 x square. So this will become a complex type of element. Then again I'm increasing this to four nodes, then t will become, or interpolation function will become a1 plus a2x plus a3 x square plus a4 x cube. So this will become a equation cubic equation. So this is a cubic equation and this is a complex equation for a simple 1D element. For a simple 1D element. So these are the interpolation functions formulation. Then for 2D element, so 2D elements, if considering a 2D element, suppose this 2D elements means ins x and y will increase in this. So what will be the interpolation function? Interpolation function will become t equal to a1 plus a2 x plus a3 y. So this y will get included in this. So it has three nodes. Okay, this element is a single element. It has a three nodes. Suppose again we increase a intermediate node in between this element. Suppose in this way, if we increase it, three nodes are increased, so it becomes 6 nodes. So what will be the interpolation function? Will be t equal to a1 plus a2x plus a3y plus a4xy plus a5x square and a6y square. So it will increase the second order interpolation function. So it will goes to second order interpolation functions of a quadratic element. Okay, so this is for the 2D element. Now I will drop this first one. Okay, so now for multiplex element, so we have covered simplex element, what will be the interpolation function. For complex element, what will be the interpolation function, cubic function, then cubic equation we have find it, second order interpolation function we have find it in 1D and 2D element. Now for multiplex element, so suppose this is a x and y, and there is a quadratic element in between this having four nodes, four noded quadratic. So this is a simple linear. So what is difference between the complex and the multiplex is that at so this side will be parallel to x and this side should be parallel to y. Always it should be parallel to this x direction and y direction. So for that, so t, the interpolation function will be t equal to a1 plus a2x plus a3y plus a4xy. The interpolation function will become, suppose if this quadratic element is not parallel or it is like this. Okay, suppose it is in this way. Okay, then we have to consider an imaginary natural coordinate axis. Suppose for that this will be the axis, so it's always parallel to this and this should be parallel to y. So suppose this will consider as zeta and this is eta, and this is your x and this is your y. Okay, now this is the imaginary natural coordinate system. So for that we have to convert this. Suppose this will be your then quadratic element. I converted this and this is will be your axis. Then what will be the coordinates here? It will be 1 1 1 1. In the second quadrant it will be minus 1 and 1. This will be minus 1 1 minus 1, and this will be 1 and minus 1, and this axis will be eta and this will be your zeta. Okay, now what will be the this quadratic equation will change to phi equal to phi equal to a1 plus a2 zeta plus a3 eta plus a4 zeta into eta. Okay, so depending upon the element, and we have to change the equation for that. Okay, so this is all about the all three types of elements. So this comes under the first one, this and this will comes under simplex. This also will come under simplex. If it is given in x and y direction, then will it becomes multiplex. Then this will becomes in complex. But suppose this should be a straight line, it should be a linear one. Okay, if it is in this way curves, then it will become a multiplex type of element. So all these are multiplex types. So this is a simplex. Okay, this is a simplex one. Okay, so in this unit we have four types of analysis or problems we have to go through. The first one is a linear interpolation problem, and second one is a plane stress problem, and third plane strain problem. So in this the equation will remain, one minute, in this the equation only changes somewhat, equation remains same, and d value will only change, that is related to the material properties. Okay, so at that time of I will tell you what are the equations for plane stress and plane strain. And the fourth one is a axis symmetry problems. So in this unit there are four types of analysis we are going to see. So first of all, we will start with a simple three-noded triangular this element method. So this is a derivation. So suppose in this diagram is shown an element. This is the element 1. Okay, so this is the element having three nodes. This node number 1, 2, 3. So in this derivation, consider this element A, B, C. We can consider as A, B, and C. So A will be become x1, y1, B equal to x2, y2, C x3, y3. Okay, having three nodes. Okay, so as the problem is a 2D, as this problem is a 2D, we can express the general polynomial to represent the solution of the problem as u equal to c0. This is a polynomial equation, c0 plus c1 x plus c2 y. Okay, interpolation function where u is the primary variables, okay, at node number 1, 2, and 3 respectively. So you can take as a u1 for node number 1, u2 for node number 3, and u3 for node number 2, and u3 for node number 3. So what will be the equation then? Therefore u1 will become u1 equal to c0 plus c1 x1 plus c2 y1. Okay, then u2 will become c0 plus c1 x2 plus c2 y2. and u3 will become c0 plus c1 x3 plus c2 y3. Okay, so uh, so this equation, polynomial equation, can be converted or can be expressed in the matrix form. What will be the matrix form? It will be in this way. U1, as we use for 1D element analysis also, U1 U2 U3 equal to matrix form 1 x1 x2, sorry, y1 y1, then 1 x2 y2, 1 x3 y3. Okay, so 1. Okay, and c0 c1 and c2. Okay, so this way we convert it into a matrix form. Then uh, then if c0 c1 and c2 equals to, we're changing the position, then what will be the matrix then? 1 x1 y1, 1 x2 y2, and 1 x3 y3. So it will become a transverse of this matrix, and u1 u2 and u3. Okay, so we have to take this c0 c1 and c2 is equal to this m. So what is this m? Is the uh, is the matrix constant for the element, this triangular element. So inverse of this will become m inverse equal to adjacent of m divided by determinant of m equal to n transpose upon determinant of m. So where this n is the matrix formed by the cofactors of element, that is this matrix m, this matrix m. So where n is the matrix formed by cofactor of element matrix this m. Okay, so now we can take this capital N equal to the matrix. Okay, so you know uh, how to multiply the matrix. First will become this x2 into y3, then minus x3 y2. Okay, so in this way we have learned in the matrix in m3 and m2 subject. So in this way we have to cross multiply that. So the matrix will become this x2 y2 y3, x2 into y3, then minus x3, this x3 into y2. Okay, then next one, what will be that? Y3 will multiplied with 1, y3 will be multiplied by 1, and y2 will be multiplied by 1. So here it will become minus y3 minus y2, then again in this way multiplication, that is x3 and minus x2. Okay, Then similarly we can change for the second, we have to eliminate this, we have to use the first row and the third row for multiplication. Again same method we are going to use, minus x1, x1 will multiply it with y3, x1 y3 minus x3 and y1, okay, y1, then again y3 minus y1, then again x3 minus x1. Now for third row, we have to consider this first two row for multiplication, and what will be the answer will be x1 y2 minus x2 y1. Now uh, where the minus will come, we rewrite this matrix again. So again, after rewriting, what we will get is that this will remain same, x2 y3 minus x3 y2, then y2 minus this minus sign and this minus sign will become plus sign, so we'll take y2 minus y3 and x3, and then x2, so for that minus x2 and minus x3, okay. Again here we have to take x3 y1 minus x1 y3 plus minus, we converted that, and y3 minus y1 in bracket x3 minus x1, and again x1 y2 minus x2 y1, and this y1 minus y2, and here we take minus x1 minus x2, okay. So we converted this matrix. Now instead of writing this all x3 and we can take constants as alpha 1, alpha, beta and gamma. We can use that constant, so uh, where we will consider this alpha 1 will equal to this first one, that is x2 y3 minus x3 y2. Similarly beta 1 will become this y2 minus y3, and gamma 1 will become minus x2 minus x3. So I will write this directly as matrix will become alpha 1 beta 1 gamma 1 alpha 2 beta 2 gamma 2 and alpha 3 beta 3 and gamma 3. Now in the first equation, where here this equation, suppose this is equation number will take as 1, so in that again what will be this changes will comes to use that. So m transfers equal to 1 upon this inverse, m inverse equal to 1 upon this transverse m and into alpha 1 beta 1 gamma 1 alpha 2 beta 2 gamma 2. alpha 3, beta 3 and gamma 3. So in exam they can ask you this derivation for 8 or 10 marks. Okay, so now uh, so this determinant of m equal to 2a. So what is the a is the area, a is the area of this triangular element, area of triangular element. Okay, that is triangle eb in c. Okay, so now we can substitute in this equation number, so this will be equation number 2 and this will become equation number 1. Okay, so we substitute this in equation number 1, substituting in equation number 1. So it will become C0 C1 C2, this is the equation, equal to 1 upon 2a in bracket alpha 1 beta 1 gamma 1 alpha 2 beta 2 gamma 2 alpha 3 beta 3 gamma 3 into u1 u2 u3. Okay, so if we take C0, C1 and C2 separately, then what will be the equation will become C0 equal to 1 upon 2a in bracket alpha 1 will multiplied by u1 plus alpha 2 u2 plus so alpha 2 alpha 3 u3. Okay, then c1 equal to 1 upon 2a, then here we get beta 1 with u1 plus beta 2 u2 plus beta 3 u3. So column versus column multiplication, then c2 1 upon 2a gamma 1 u1 plus gamma 2 u2 plus gamma 3 u3. So now substituting this equation, we can get u equal to substituting in equation in 5 point, so sorry, in the first equation here, in this equation, this one, suppose I'm equation number this one Roman 1, this will become equation number 2, this will become equation number 3. Okay, then equation number 1, so here we have to change this to 2. Okay, then what will be the equation then? Capital U equal to 1 upon 2a alpha 1 u1 plus alpha 2 u2 plus alpha 3 u3 plus 1 upon 2a for beta 1 and so on, beta 1 and then gamma 1. Okay, and so u equal to summation of this 3 node I equal to 1 to 3 ui phi I. So the shape function for this triangular element will be equal to phi 1 equal to 1 upon 2a and alpha 1 plus beta 1 plus gamma 1 y, then phi 2 will become 1 upon 2a alpha 2 plus beta 2 x plus gamma 2 y, and for phi, this is phi 2, is phi 3 equal to 1 upon 2a in bracket alpha 3 plus beta x plus gamma 3 y. Okay, then you have to take the derivatives. If they ask in the problem derivatives of this phi 1, phi 2 and phi 3, what will be then become in this way. Derivative of phi 1 by dx dy dx equal to beta 1 divided by 2a, and for y it become phi 1 upon dy equal to gamma 1 2a. Okay, similarly for phi 2 and phi 3. So this all are the strains for linear triangular elements, and this derivatives, if they ask you for a strain to find out the strains for your element, then you have to use this equation for linear triangular element. Okay, and when the plane elastic problems are asked, then you have to go for the constant strain triangular element system. Okay, so what is CST system, we will cover after this covering of your first type, that is a linear interpolation problem. After this we are going to plane stress and plane strain. At that time I will show you the derivation for CST, that is a constant strain triangular system. So stay tuned for the problems for this type of derivations. There are almost 3 to 4 problems over this linear interpolation, so we will cover in the next session or the next lecture. Okay, thank you for listening.